Speaking of transformations, so here's the general form of an exponential function where we have different pieces. So that a is being multiplied by the parent function. So that is our vertical stretch by a factor of absolute value of a. If that a is greater than 1, we have a vertical compression. In other words, it shrinks by a factor of the absolute value of a if that absolute value of a is in between 0 and 1. Now, if that a is negative, remember those negatives means that we have a reflection. If you're multiplying those output values, which are the y's, by a negative, that means it's going to reflect over the x-axis. If the x value is being multiplied by a negative, then the graph of f of x is reflected over the y-axis. Just think if you multiply those x's change signs over the y-axis. Then we have this c up here, x minus c. Remember, when you add or subtract from x, that means we have a horizontal shift left or right, but it's always in the opposite direction of that sign c. Our last one, d, same thing, vertical shift, but it shifts in the same direction as d. So it's going to go up or down. Remember, the rules for transformations are all the same. They just look different because you're dealing with different parent functions. In this example, we want to use transformations to graph the function f of x equals -2 times 3 to the x plus 4 minus 1. Well, our parent function would be 3 to the x. So we can graph that one first, maybe dotted. You can do this if you still want to, the -2, -1, 0, 1, and 2. To the -2 power would give us a 1/9, so really small here. To the -1 would give us a 1/3. To the 0 power would give us 1. But then to the first power would give us 3, and squared would give us 9 up here. So I'm going to dot this guy. That's our parent function, just 3 to the x. Now let's take a look at what's happening to this parent function. It's being multiplied by a -2. So the -2 times 3 to the x, that means it's being stretched by a factor of 2 and reflected over the x-axis. So we would take every y value and multiply it by 2. If we were to do that in green, if I were to multiply 1 by 2, he would be up here. If I multiplied 3 by 2, he would be up here at 6. If I were to multiply the 1/9 by 2, there'd still be 2/9. So take all of those points in green and reflect them over the x-axis. So instead of a +6, we'd be down here at a -6. +2 would be down at -2. 2/3 would be down here at -2/3, and 2/9 would be -2/9. So that is the -2 times 3 to the x. But now we have to deal with our horizontal and vertical shifts. So we have -2 times 3 to the x plus 4, and that entire function is -1. So what does that mean? X plus 4 means we're going to shift left 4, and the -1 means we're going to go down 1. So remember, the change in x is going to be the opposite as what you think. +4 is actually left, but the y change, that d value at the end, works the way we want it to. -1 is down 1. So we're going to take all of those values in green, and we're going to shift each of those points left 4 and down 1. So over here at 1, -6, we're going to go left 4 and down 1. Try to make that dot big there. 0, -2, we're going to go left 4 and down 1. -2/3, 4 and down 1. And a -2/9, 1, 2, 3, 4, and down 1. So before I connect the dots, remember the parent function had a horizontal asymptote at y equals 0, which means if the whole function moved down 1, that includes the asymptote. So I have a horizontal asymptote here at y equals -1. That will help me when I draw and connect the dots for this function to know that I need to stay below the y equals -1.